Welcome to International Conference on Emerging Techniques in Computational Intelligence. My name is Rosli Boylindo, and on behalf of my team, I'm going to give the presentation on AVHYAS, which is basically stands for Advanced Hyperspectral Data Analysis. It's a free and open source Quantum-GIS plugin for advanced hyperspectral image analysis. We are a team from Indian Space Research Organization working in Space Application Center, and our area or main focus of research is in developing advanced technique for hyperspectral data analysis. In the next 10 to 12 minutes, we are going to cover a few of the agendas, and the outline of the presentation will start with the background or motivation behind developing the software. We're going to see the scope of the software, the design consideration of the software, some of the functionality which AVHYAS provide. We're going to see some of the case study which we can make use of AVHYAS for different application. And we are going to wind up with the future scope or the plans which we have for future releases of AVHYAS. We'll start with the background. So basically, we know our hyperspectral data is a high-dimensional data with a very rich spectral information, and most of this information are highly correlated, and it's mostly affected by noise. So both systematic, non-systematic, as well as some atmospheric effect will be there. So mixing happens within the field of view of the sensor as well, mostly for spaceborne sensor. And so all these things adds to the complexity in handling hyperspectral data. That's why we need advanced algorithm to handle hyperspectral data. At present, any advanced algorithms such as deep learning and many nonlinear models for unmixing bilinear models are not available in any commercial open source software, which we have provided in our software. And advanced algorithms which are available in different scripting languages, either they are written in C, C++, Java, Python, or most of the time MATLAB, they do not provide any user interface which beginners or users with no prior programming skills can use them. And over the last few decades, Python has grown as a language, and quite tremendously the growth we can see, partly because machine learning models and deep learning models rely mostly on Python for that. And the beauty of Python is that it makes programming tasks quite easy, because in a few lines of code we can perform different programming tasks. We rely mostly on Quantum-GIS as the backend, because we do not want to build and develop from scratch all the GIS capability, all the visualization capability, because Quantum-GIS already provided. And Quantum-GIS also provide a platform for developing and making use of its user interfaces by giving a platform in the form of plugin. So we have developed a plugin for Quantum-GIS, which we can use all the capability of GIS, of Quantum-GIS, and all the GIS functionality of what Quantum-GIS provide. And Quantum-GIS has vastly successful because it is constantly being improved by many of its active community, because they are constantly working to improve the software. So these are some of the things from our background which motivate us behind AVHYAS to build it on top of Quantum-GIS. The scope is what we have planned is that we want to make sure that AVHYAS is provided free and make sure that it is as user-friendly as possible for both beginners as well as advanced users. And all the modules which we have provided, they are both applicable to multispectral data as well. So some of the modules which we have, which we are like using for hyperspectral data here, if we have multispectral data, we can use that. We can use AVHYAS even for multispectral data analysis as well. AVHYAS plugin basically bridges the gap of Quantum-GIS, because Quantum-GIS is a GIS software. It does not necessarily have all the like modules to do hyperspectral data analysis. So we want to bridge that gap between what Quantum-GIS has and what it has not. So by providing and enhancing its capability even for handling hyperspectral data. And we rely mostly in different Python packages like TensorFlow for deep learning, scikit-learn for machine learning, and other modules as well. And we are at the moment supporting Windows like operating system. There's a support for Linux as well. It does support, but we are not testing it rigorously as we have tested for Windows. And there are other things also which are available in AVHYAS, which are not available in other proprietary software as well as other open source software. We are making sure that they can handle both spaceborne and airborne hyperspectral center. And our main focus is to develop advanced algorithm and make sure to make it available for all the research community free of charge, and we are making sure to make it as user friendly as possible. The design consideration, we rely on Quantum-GIS 3.14, and it has built-in Python 3.7. So we rely on Python 3.7. All our modules are dependent on Python 3.7. And at the moment, the stable version which we have supported is Quantum-GIS 3.14. And it does support for any version above 3.14 as well. We have different modules which we have here. Some of the silent feature which we have here is machine learning classification modules, the deep learning classification modules, regression models, process modeling, some of the atmospheric correction models which we provide, some of the compressed sensing cloud removal methods which we provide. We have also provide data management for spectral radiometric data as well. There are other data for severability analysis as well, which we have provided here. So the different modules are there, which we can see in the next slide. So we have incorporated as many modules as possible, right from the start to the end of whatever we can do with hyperspectral data, right from atmospheric question to the application part. So we have atmospheric question, but at the moment it only support for AVIRIS-NG. In the future, we may add a generic atmospheric correction module as well. We have provided a pre-processing module, right from dimensional reduction, feature extraction, feature identification. All those modules are also provided. We have the basic tool from plotting, scatter plotting, spectral library viewer, sensor utility. All these things are also provided. We have also the data quality analysis module, which basically check on the data quality like noise, denoising, destriping. All those things are also available here. Spectral unmixing and deep learning are few of the salient feature which we have provided here. Unmixing because it's like one area of research which is constantly growing nowadays, and people are mainly focusing on many advanced non-linear mixing models also. We have provided end-to-end mixing modules here, right from the n-member estimation, n-member extraction, and then the abundance estimation as well. The deep learning part, classification part, regression part, all also are available. The deep learning, in the sense like we have provided and implemented all whatever are available in the journals and like whatever has been published, both 1D, 2D, 3D, all the convolution neural network as well as multi-layer perceptron models are all being implemented and provided in here. All whatever the users wants is just have to go to the deep learning modules and use it. We have also provide some of the other miscellaneous application which we can make use of hyperspectral data, like target detection, data fusion, spectral indices, geophysical parameter application. All these things are also provided as a module in AVHYAS. So we are going to see some of the case study which we can use using AVHYAS. So like classification using deep learning models. As we know that deep learning has become the talk of the moment so far. And if you look at the research community and the number of papers which are being published using deep learning, they grow day by day. And any topic we take, like deep learning has entered into that field. So we have provided here different deep learning models which are being published and which are being accepted. Here, right from the 1D convolution neural network to the 2D to the 3D, as well as to some of the advanced, as well as in-house built models as well as were provided here. Fusion is also another area of research which many people are working on. Like we have a paper of our own team, which we have published very recently. That module is also provided in here. Anyone who wants to use any fusion technique for hyperspectral multispectral data fusion, we can go and download our software and straight away use the hyperspectral multispectral data fusion. So we have other silent functionality as well, like separability analysis. Most of the time when we go to the field, we collect the data. And when we come back to our lab, we can make use of our software to do any sensitivity analysis, any separability analysis, any kind of analysis with our ground truth data. That module is also provided. Segmentation, we have provided our own advanced algorithm, which we have developed recently. And it's being accepted and published also recently. And that module is also provided with some other traditional modules which basically uses for hyperspectral data segmentation are also provided. We have also provided some of the simulation technique. For example, we have AVIRIS-NG, which is like a very good data, both spectrally and spatially. So if you want to simulate any hyperspectral data, for spaceborne hyperspectral data at 30 meter, we can do, and we can use AVHYAS to do that for you. You can just simulate those data. And for example, we can use that data for testing of hyperspectral, multispectral data fusion or simulation, or for any other research work which you want to use. And the other things which are provided is like a case study is like for spectral radiometer data analysis. We have added that it has a capability of handling raw SD data, and it has support for other spectral radiometer data as well. We have provided an atmospheric correction module as well, and this atmospheric correction module at the moment is only supported for AVIRIS-NG. However, we plan to add a generic generic atmospheric correction module as well in the future releases. So we'll wind up with the future scope which we have. We'll make sure we'll provide wavelet-based spectral analysis in the future releases. We'll add and make like the handling of AZ data more prominent by adding a proximal spectral analysis tool with that. We are working on time series hyperspectral data, and in the future releases, we are hopeful that we can add time series hyperspectral data analysis as well as a module. We are working on deep learning as well for data fusion, super resolution, as well as deep learning based on mixing. All these modules are also like planned and scheduled to be added in the future releases of AVHYAS. At the moment, our main aim was to provide a functionality with little focus on the processing speed. So in the future, we'll plan to even increase the speed as well. AVHYAS source code at the moment is not available in the public, and we'll make sure to push it in the public as soon as possible. And we are targeting to submit it in the Quantum-GIS repository as well, so that anybody can download from the Quantum-GIS repository. At the moment, you can download it from the link provided below. There's a feedback form that is available at the site. You can give your valuable feedback to us so that we can improve the software and make that software to be handy and useful for different research and user community. And that is all from me. Thank you for being patient and listening to me. Thank you very much.